In question 24, we are seeing that there's a lab car. It's moving according to the velocity time graph shown above. We've got a velocity time graph, so of course we're going to Eulerge it. So the origin, we can see, is right there. That's 0, 0. So we are looking at a situation on the coordinate plane where our graph is there. So yes, 0, 0 is in the field. Y-axis is velocity, x-axis is time, meters per second, seconds, normal units. So the things we can read are velocity and time, so any questions about velocity and time we'll simply read off the graph. The gradient, delta v over delta t, is the acceleration, so any question about acceleration will be related to the slope. And the area is v times t, which is meters per second times seconds, which is displacement. Any question about displacement will be related to the area. In analyzing the graph, what we see happening is we start out with a velocity that's positive, and it decreases to 0. So if we have a number line, so we don't know exactly where we're starting, but let's say we did start at 0. When in doubt, start at 0. And it's traveling quickly, but we see it's then slowing down. And velocity of 0 is at this point here. And then it starts getting negative velocity. And if we notice, the slope is the same, so the acceleration is the same. So on the way back, the dots would be spaced the same way. Now, this idea of displacement we know is tied to the area. So if we look at this positive area, and then we look at the negative area, that happens at about 7 seconds. So at about 7 seconds in the other direction, we would be at 0. I'll say that was 8, so maybe 16 seconds. Let's say that number there is about 8. So at 16 seconds, it would be even. And any of the additional area then is all negative area. So even though this thing continues to speed up beyond, let's say it goes even further, it then starts to slow down. But all the while, continuing to move in the negative direction, and eventually it comes to a stop. But the entire time it's moving in that direction. The velocity over this entire time, here is negative. So at that entire time, all the way to 25 seconds, it's moving negatively. All right, so we have an understanding here of what's going on. Moves according to that graph. The student is asked to determine the cart's displacement in the first 20 seconds of the cart's motion. All right, so the first 20 seconds of motion we see is to here. Now, we've already figured out what's going on here, that this thing has returned to its original spot and gone further. And the farther amount is given by the purple area between the purple and the red line. His response, which is partially incorrect, is shown below. So let's see. The car's displacement is the area under the velocity time graph from time 0 to 20 seconds. So we take this first clause, and this is true or correct. The area is shaded above or below in gray down here. Okay, so they're just telling us that. That's a given. The area of the triangle is 1/2 base time height. For this triangle, it's 1/2 of 20 seconds times 2.5 meters per second. Now, the 2.5 would come from this 1 and this 1.5. So that is true. That height is 1.5. All right? But we can see this is the problem. The student thinks all the area is positive, and so the student has incorrectly identified the area involved. All right, so we now understand, we know that this is incorrect. They've identified the wrong area. Now, what's the question? Explain the errors in the student's solution. Oh, so it's easy. The errors are the student incorrectly identifies, notice there's error or errors, the region whose area should be calculated. It's the area between the curve and the x-axis, not literally under the curve. And if you look what the student did, that's actually what it is. They actually took it literally, area under the curve. Area under the curve means area between the curve and the x-axis. Is there another error? Yes. Yes, there is another error. So error number 1. Error number 2. The student doesn't recognize that there is negative area. So concludes that all displacement is positive. Next question, does the student overestimate or underestimate the car's displacement in the first 20 seconds of its motion? Explain your answer. Well, let's see. We said that this is the displacement. That this here is the displacement. This student has this gargantuan number. So, the student overestimates the car's displacement. Since the student counted all motion displacement as positive, they failed to account for the negative displacement that occurs after the cart stops and reverses direction at t equals 8 seconds. All subsequent displacement is negative and thus subtracts from the earlier positive displacement. So we want to see now if we have fact, observation, and logic here. Logic conclusion. And so we say this here. The overestimates the car's displacement. Since the student counted all the motion as positive, they failed to account for the negative displacement that occurs after the stops. All right, so we've got some observation mixed in with our conclusion here. Perhaps if we were going to, because there's a series of questions that follows from this, we've already explained that area is the displacement. Did we say that? Oh, we weren't asked to. We should say that implicitly. The area is, actually we did say that up here. The area is the displacement. Just want to make sure we include that in there somewhere. That's the type of thinking we want to have for this question.